Today we're going to talk about graphing quadratic equations, quadratic functions, and these functions are particularly in vertex form. So before we get into the actual graphing, I want to talk to you about what vertex form is and how it can give us some important information about the transformations that are occurring in the functions we are graphing. The three main parts that we're going to look at in a quadratic function that is written in vertex form are the a, the h, and the k. So the a tells us two very important things. It tells us about the direction of opening because all quadratics are going to be parabolas when we graph them. And so if we look down here at direction of opening, if the a is a positive number, then we know the parabola is going to open upward. And if the a is a negative number, we know the parabola is going to open downward. Another thing that the a tells us is it tells us about the vertical stretch or compression. Just to kind of give you a visual, if the a is any number greater than 1, this could even be 1.1. It can have decimals as long as the number is still bigger. So if the a is bigger than 1, you're going to see a vertical stretch occur. What this means is you're actually stretching up and down. If you had a visual of like holding a piece of gum and you pulled that gum upward and downward at the same time, you would notice that this piece of gum would get very tall and very narrow. Same thing is occurring in your graph. If the a falls between 0 and 1, that makes it a fraction, or it could be a decimal also, like 0.5 or 1/2. In this case, you're going to see a vertical compression. So think about that same piece of gum. If instead of stretching it, we decided to squish it between our fingers, what would happen to that gum? It would get flatter and wider. Same thing occurs in our graph. So the a tells us some important things. Next, we're going to look at the h and the k. The first thing that h and k tells me is the vertex. Notice in the vertex form function, the h is negative. But down here, when I identify the vertex, it's positive. So I've written this down. H is always going to change signs when you take it from the function to writing it in vertex. K will remain the same. If the k is positive in the function, it'll be positive in the vertex. If it's negative in the function, it's going to be negative in the vertex. All right, so since h and k are used to write the vertex, I want you to remember that every point is my x and my y when I'm putting it on an xy axis. So the h corresponds to the x. And if you think about a graph, the x-axis goes from left to right. So when I'm graphing the vertex point, it tells me if the graph is moving left or right. The k corresponds to the y, and y-axis goes up and down. So again, as I'm graphing that point, I can tell you if this graph is moving up or down. So let's look at a problem and see how this works. In number 1, you can see I've got my function. It's written in vertex form, but you might notice that instead of y equals, they've written f of x equals. Don't let that throw you off. F of x and y are completely interchangeable. The first thing that I'm supposed to identify is my vertex, and I told you that the vertex comes from the h and from the k. I told you something very important about the h. The h will always change signs, so it's going to become positive 5, and the k will remain the same, positive 2. This will be the very first point that we put onto our graph. As I'm putting this point on the graph, I'm going to talk about where I'm moving because my starting place is always 0, 0. To graph this point, I have to go right 5 and up 2. That is the transformation. Right 5, up 2. Now we're going to talk about the y-intercept, and we're going to go ahead and put some points on our graph so that we can sketch it. I do know that this particular parabola is opening upward because the a, which is a 1, is a positive 1, and positive graphs always open upward. In order to get another point, I'm going to look for the y-intercept as a possibility. One of the things that I want you to realize about all parabolas is that they have symmetry, which means if you folded them in half, every point on the left would have a mirror image point on the right. So a lot of times you will see an axis of symmetry line drawn right down the middle of a parabola. It just shows you where you would fold it. To find the y-intercept, all we need to do is plug a 0 in for the x, because the y-intercept tells me if I was to sketch this graph, where would it cross the y-axis? And in order for my graph to cross the y-axis, x would have to be 0. So I'll plug that into my equation. Y equals 0 minus 5 squared plus 2. I'm going to get an answer for this, but at the same time, I want you to realize this is a point. I've just plugged a 0 in for the x, so that means that x is 0, and I'm going to get an answer for the y. 0 minus 5 is negative 5. When I square that, I get 25, and when I add 2, I get 27. Now looking at my particular graph, 27 is not graphable here. I would have to have a much larger xy axis in order to do that. So I need to pick a point that I actually can see on this graph. This is where your graphing calculator can come in and help you a little. Let me pull up my graphing calculator so we can talk about this. The first thing that I want you to do on your graphing calculator is I want you to go to mode. When you go to mode, I want you to select graph table mode. We're always going to graph in graph table mode because there's so much good information in this mode that can help us with the graphing process. Your calculator may not have the words written out. It might just say GT, but it means the same thing. Once you've selected it, I'm ready to graph. So I'm going to go to the y equals, and I'm going to put my equation in this first line. Now, when you're entering the equation, you don't need to enter the y side of the equation, only the right-hand side. So I'll enter parentheses, x minus 5, parentheses, and I'm going to square it. You can use this x squared button to do that. Then I'll put plus 2. Once you have your equation entered, I want you to hit the graph button. Now, here's what's cool about the graph table. Every single one of these represents a point on the graph. Notice what you see right here at the top, 0, 27. That's the point we found, the y-intercept. I can also see my vertex point on there, 5, 2. One of the things I want you to realize with a parabola, you see this repetition that's occurring. Here's my vertex, and then both of these have a y of 3. Both of these have a y of 6, 11, 18, 27. Those are my pairs. That's that symmetry that I was talking about that occurs on your parabola. So I'm just going to pick one of these pairs. Since 5, 2 is my vertex, I could pick the pair above and the pair below. So 4, 3 and 6, 3, and I'll graph them. So back here, 4, 3 is right here. 6, 3 is here. I'm going to sketch my graph. Again, if I wanted additional points so I could see how wide it is, I can just open up because this one's kind of close. Let's pick another one. How about 3, 6, and 7, 6? So 3, 6 would be here, and 7, 6 would be here. That's enough points to give me a very good visual of what this parabola will look like. Always remember to take your parabola to the ends of your graph and draw arrows to show that it does continue upward. All right, we're done with number 1. Now we can go through number 2 a little bit faster. In number 2, the first thing I'm going to do is identify my vertex. Remember, the h changes signs, the k stays the same. So my vertex is -2, -1. I'm going to go ahead and put that on my graph. And as I'm putting it on the graph, I'm going to talk about where I'm moving. If I start at 0, 0, in order to graph that point, I have to go left 2 and down 1. Those are my transformations. Left 2, down 1. Notice, and I don't think I referred to this in number 1, but neither one of these have an A that is written. Both of them have an A that is implied. It's a 1. And if the A is 1, I do not have any vertical stretch or compression. So that's why I did not write that for either one of these transformations. All right, so now it's time to find the y-intercept, because just like in this one, if it's something close, then I won't have to pull out my graphing calculator. I can just use it and do the mirror image. Also, like I did in the last example, I do like to sketch that axis of symmetry as a dotted line, because that tells me that this is my symmetry line, and anything that occurs on the left, I'll have a mirror image point on the right. So on my y-intercept, I'm going to put a 0 in where the x is. Y equals 0 plus 2 squared minus 1. Remember, this is a point. It's telling me that when x is 0, what is y? I'm getting ready to tell you. 0 plus 2 is 2, 2 squared is 4, and 4 minus 1 is 3. Now this is a point on my graph that I can go ahead and put down. 0, 3 is right here. So how do I use that mirror image? This point is 2 away from the axis of symmetry. So if I go 2 to the left, here's its mirror image. And that's enough for me to sketch the graph. Remember, this should have a U shape, not a V shape to it. And we're done. All right, let's look at number 3 and 4. Both of these are good examples where we can see some vertical stretch and compression. All right, in number 3, let's start by finding our vertex. The H and K tell me the vertex. Don't forget, change the sign of the H, so it's a positive 3, and K remains the same, positive 2. Now let's graph it, and let's pay attention to if we start at 0, 0, where are we moving? In order to graph this number, we would move right 3 and up 2. I'm going to go ahead and write those transformations down now because they're my first 2 transformations. Right 3, up 2. Now, since there is a number at the front, 1/2, I know that I have vertical stretch or compression occurring. And we talked about that when you have a fraction, it's vertical compression. So I'll go ahead and write that down. Vertical compression. And a lot of times when they write this, they'll say by a factor, vertical compression by a factor of 1/2. It's kind of a lot to squeeze into that spot. All right, now we want to find our y-intercept. The y-intercept is where this graph is going to cross the y-axis. I do know that it is opening upward because my A is positive. So as I draw it, it's going to cross somewhere over here, but I don't know where yet. So remember, the y-intercept means that x is equal to 0. So I can put a 0 where x is in my equation. Y equals 1/2, 0 minus 3 squared plus 2. This is my first point. When x is 0, what is y equal to? Well, I can take these numbers on the right-hand side, and it's fine if you want to use your calculator to plug these into your calculator. If you can do these in your head, that's fine also. 0 minus 3 is negative 3. If I square that number, I'm going to get positive 9. 9 times 1/2 is 9/2. And if I add that to 2, I have to get a common denominator, which would be 4 halves. 4 halves plus 9 halves is going to give me 13 halves. Now, when it comes to graphing, sometimes an improper number can be hard to graph. So you may want to think of this as a mixed number. 6 1/2 is a lot easier to graph. 6 1/2 would be about here. Now, if you have put the dotted line for your axis of symmetry, you can use this to help you with finding where that mirror image point will be. Remember, I'm going to go straight across, and in the same location, I'll put a point on the right-hand side. This point is currently 3 units away from that axis of symmetry, so I will go 3 units to the right and put its mirror image point. Now I can go ahead and sketch my parabola. Remember to keep it U-shaped as you sketch it. All right, number 4. In number 4, I'm going to start by identifying my vertex. The vertex is +3, -3. Because remember, I'm looking at these 2 points, H and K. H changes signs, K stays the same. Now we're going to graph our vertex, and we're going to pay very close attention to where we're going. When I graph, starting at 0, 0, I move right 3 and down 3. So those are my first 2 transformations. Right 3, down 3. Now I'm going to look at this front number, the A. The A tells me 2 things. It tells me that my parabola is going to be opening downward, which is different than our previous 3 examples. It also tells me that since this number is bigger than 1, this is going to have vertical stretch. It's going to be a taller, narrower graph. So I'm going to go ahead and on my transformation, I will write vertical stretch by a factor of 3. Now, we can go ahead and sketch our axis of symmetry line to help us keep things balanced. And let's find our y-intercept. Remember, to find the y-intercept, we plug a 0 in for x because we want to see where it crosses the y-axis. So I've got y equals -3, 0 minus 3 squared minus 3. And this is my point. When x is 0, what is y equal to? Let's talk about it. 0 minus 3 squared gives me a 9. 9 times -3 is -27. And -27 with a -3 is -30. Well, when I look at this graph, I don't go all the way down to -30. So it's a good time to pull out our graphing calculator, and let's talk about how to graph using the calculator. Let me scoot this over so we can see everything good. Clear out any previous graphs that you have on your y equals, and let's enter our equation up here at the top. So I've got -3, parentheses, x minus 3. Don't forget to square your parentheses, and then do a -3. We can go ahead and graph this. And again, having this table helps verify some of my previous answers. I can see that yes, the y-intercept is at 0, -30, just like I found here. And my vertex, you can see the only one that doesn't have a pair is this one, 3, -3. So that is correct also. So as far as finding some additional points, find your vertex point, and then you can pick some points above and below that you could graph. I'm just going to do the one directly above and the one directly below. So 2, -6 and 4, -6. 2, -6 would be here, and 4, -6 is here. Like I said, this graph is narrower because we have that vertical stretch that's occurring. For these next problems, 5 through 7, they're going to give us a vertex point, and they're going to give us a random point on the graph, and we are going to write the vertex form of this quadratic equation. So just to keep in mind, vertex form is y equals a x minus h squared plus k. Now, things that they're giving me, when they give me the vertex, they are giving me the h value and the k value. And when they give me a random point, they're giving me the x and the y. So in this equation, we are going to fill in everything except for the a. We're going to solve for the a, and then we will use that to write our final equation. So in step number 1, we're going to fill in these 4 items. Now notice, don't forget this minus sign. When we plug the h in, we need to use parentheses around that h. So I've got y is 17 equals a. My x is 0. My h is -2. And my k is 3. So now I'll just clean things up. I've got 17 equals a. Let's find out what all of this is. When I do 0 minus a -2, so 0 plus 2 gives me 2, and then I square that answer, I get 4. Now, if I'm solving for a, I need to start moving things away from the a so that I can get it all by itself. So the first thing that I'll move is I'll subtract 3. That gives me 14 equal to, and I'm going to write this as 4a. And then I'm going to divide both sides by 4. And I get a equals, both of these are divisible by 2, so I get 7/2. After I do this, now I can take my a and my h and my k, and this is how I will write the final answer. I no longer need the x and the y. So my final answer will be y equals, I'll put the a in, 7/2. Then I have x minus h. So it's going to change the sign because I have minus a -2. That becomes plus 2 squared, and the k will remain the same. It's positive, so it stays positive. And this is my final answer. You can check this answer to see if it is indeed correct, just to see if you're on the right track. If you'll pull up your calculator and you graph this equation that you wrote, so let's go to y equals, and we'll clear it out, and let's put alpha y equals enter, so I can put my fraction 7/2, and then I'm going to do parentheses x plus 2. I'll square that parentheses and add 3. I'm going to graph it, and I'm looking for some specific things. Does it have a vertex at -2, 3? You might look over here at your table and you can't see the negatives. Here's how you do it. If you want to use the table and move up and down, if you will do second graph, that enables you to use the table, and then your cursor can move up and down. And it highlights exactly where it is on the graph. So yes, my vertex is -2, 3, just like I had right here. And I do have the point 0, 17 on my graph. So my answer is correct. In number 6, we're going to do the same method. We're going to fill in the y, x, h, and k and solve for a. So in this case, these are my h and k, and this is my x and y. So y is negative 6. I don't know my a. X is negative 1 minus h, which is negative 4. I'm going to square all of that. And then my k is negative 4. So I've got negative 6 equals a times. Let's see what all of this ends up. If I have negative 1 minus a negative 4, that's the same as negative 1 plus 4. So that's 3. 3 squared is 9. Now let's solve for a. Start by adding 4 on both sides. Negative 2 equals 9a. Divide by 9, and I get a is equal to negative 2/9. So now it's time to write our final answer. And just like in the previous example, we're only going to include the a and the h and k. So my final answer would be y equals negative 2/9 x minus h. So remember, you can write down minus a negative 4, or you can go ahead and change that to positive 4. Square the parentheses, and then you'll put down the k, just like you see it, negative 4. All right, the final example, number 7, just so you can see it one more time. We're going to identify the h and k come from the vertex, the x and y come from my random point. So I have y, which is negative 10, equals a, x, which is 2, minus h, which is 4, squared, plus k, which is 2. As I clean things up, 2 minus 4 is negative 2, and when I square that, I get a 4. I'm going to start by subtracting 2 on both sides. That gives me negative 12 equals 4a, and then I'll divide by 4. So a is equal to negative 3. I'm going to use this answer, a, and I'm going to use my h and k to write my final equation. So I've got y equals a, x minus h squared plus k.